Okay, on this one here I had some fireworks with it. This hair burning up. I'm going to desolder it again and figure out the ohms. I think it's 47 ohms. I think it's yellow, purple. I think it's black. I'm not sure. It's hard to see under the windings, so can't understand why the carbon resistor would burn up. But before I burn it up again, I want to I think what I'm going to do is hook this plate up to down here so I don't wipe this thing out and see what's going on with the current or something. I don't have an oscillator in it, so we'll see. And I did not separate this and get a connection there. I'm depending on this. Maybe that's wrong. Maybe I should get a connection in there. And I still didn't put this one bolt in the tube. But so I got the power supply redone. So this wasn't that ohms, and this was the what were they set? They were yeah, 14. Yeah, both sides are 14 dot something, I believe. Anyways, I got this all color coded. The switch, standby switch, they had bypassed. I didn't know it at the time. I know it now. So I might jump this, or no, not that one. Where is it? Yeah, it is. Yeah, it is that one. So I might jump this thing. Did I test that? I don't think I tested that. I don't know what's going on here. I should test this to make sure that's not leaking and changing my biasing voltage. My biasing voltage was 30 volts. I don't think it mattered where I put the switch. Negative power supply right here is the orange trail. So I do have that switch, I guess. So I'm gonna start this thing up and burn that resistor up here a little more. Yellow, purple. I think it's black. I think there's a crack there too. So I put my digital meter on here and to here, and I get put like 0.5 or 6 ohms, which is usually what my meter will sit at. So if I go like this, I take my meter and put it here, it'll say like 0.5. It always, when you zero up, put the leads together, it always says like 0.5 ohms. So, but in the meantime, I'm still going to reheat these and reestablish a solder connection if there is corruption there. I'll probably reheat that one, but I want to first resolder it in and get that. I haven't really verified that it was right to this resistor, but I think I see a crack right there on the silver. Right there. So I'm going to hook it back up and verify this, because I wasn't near it when it went again, but I'm pretty sure it was that. So here we go. Okay, I put the other screw in right here. I broke this loose, put some Vaseline behind it, moved it, jiggled it around. It does have a star washer, but when this was cut and that was cut the way I got it, it showed open connection from this shaft or anything to chassis ground. So I'm not going to hook this in for a while because they still have this one. I don't know if that could be throwing things off, but again, I have no crystal in it, so it's just running. I'll probably pull these tubes, these ones, the oscillator. The resistors for these get really hot down below to the oscillator, and the driver. Okay, I gotta take a break here. Okay, back on. I had to remove this. Apparently I don't have it in there deep enough because it was just like laid on there and soldered. So I had to take a file to this and file it. So it was really soldering crappy, so I couldn't find my rat tail one, so I used this one. But I think it should be done better, but that resistor's shot anyway, so I will turn it on pretty quick here. See what smokes. But I put this on, so I'm hoping to get the cathode current. I don't know what it's supposed to be. I would imagine 100. If that's milliamps, I would imagine 100 milliamps to 100, what are these? 110, 20, 30, 40, 50, 100, and up to maybe 120. I'm not sure for that tube. So I think I'll hook my VTVM up to it to monitor the control grid voltage if I can. I believe I should be able to. Okay, I'm back on here. I don't know what's going to happen. I think I'm on pin 5. I think it's pin 5. It's hard to read. 5, it looks like 5. Through a choke and 820 ohm. I think I'm on the top side, that 820 ohm. It's hard to see. A little spot. My lighting here. So I'll turn this on. I'll leave it high. I don't have much time here, so I'm gonna be about a 200 volt on the negative voltage I'll need. So I'll plug it in here and have to be ready to shut it off. I think it shuts off. I think. And I put this back on. I have 2 amps low blow on each side. That's the best I can come up with at the time, because I usually have 3 amps for 2 6L6s or 5 amps for 4 6L6s, but I didn't have any 3 amps, and I don't know what it's supposed to take. Okay, so I'm going to try to be back and forth from here and especially there. So it's turned off. The first one is tune. I guess I'll just leave it on tune. That's why it's the first one. So let's see what happens here. So I should show negative voltage here right away. I think it's usually about 100 volts. Okay. Oh, this is on the other side of the resistor. So negative 30. It's supposed to be 36. Okay. We got the sun influencing me here. I did reestablish that capacitor. And I resoldered those connections on the coil to the resistor. I wonder if I have to put these tubes in to raise some hell with it. Okay, I'll pause it and put those tubes in and see what happens. Okay, back on. I had to take a drink of coffee. It might be my last sip. This thing scares me more than a freaking black and white TV. So, okay, we got that in the oscillator, and the other one, I never really verified where the tubes go, but I believe this is the oscillator because the crystals are here. That's the driver because it's there. But they had this 6DE7 here, so I could be, I don't think I'm backwards. And here's a 128T7. Whoops, that's the speech amp. So why is that so wiggly? Okay, back on. Here we go. Scarier than a black and white TV. Here we go. I should have my high voltage probe. I turn this thing. I don't know if that would, with no crystal, this shouldn't have no bearing on anything. This is about 40. Right around there. So the block where the 40 is. So I don't know. The tube's lit up. I see that. Well, maybe the problem was these solder joints on each side of the 47 ohm. But when I measured it, it measured a half a ohm, or roughly around a half a ohm, and that's usually what my meter reads. I gotta see the B plus here. I think I can touch it with my meter. We'll try. So I got negative 29 volts. It's supposed to be 35, I think, 35 or 36. Well, I smell hot resistors. The resistors on the bottom of these things get really hot. I smell them. Meantime, I'll pause this. Well, the resistors on the bottom are getting really hot. Can I just do that? This has no frequency, so it shouldn't be, just DC volts. So I should be brave enough to do that. 750. So I'll clip it in, then I can watch them both. Okay, so I'm on the far side of the resistor. Shouldn't matter. I'm at 750 volts. No, 1000 volts. DC, I guess. See what happens. She comes, should be 7.5, I think. So it's coming down 740, 739, 740. I have nothing on this. I don't have a clue what it's supposed to be. So maybe there was a hairy solder joint there that was burning the crap out of that resistor, because I couldn't believe that resistor could burn up with a spool of wire around it, a few turns of wire. So when I shut this off, I'm going to check the temperature of that coil that's vertically up in case there's issue. If that's getting hot, then I will put a wire right from the plate cap to ground. I don't mean ground to the other side. So we bypass that coil so I don't take it out in any testing of stuff. So I have both tubes in. I have them in the same way. Industrial one here, other one here, whoops, other one here. I should probably hook this up properly. I don't have that hooked. It's just sitting there waiting to be soldered in. I should do it properly. So my fire issue is gone. So I'm at 744. So pause it a minute here and flip it around and check some temperatures on components here real quick. Okay, I might have taken too long. But anyways, last night when I was checking that stuff, when the resistor went up on the plate, this 33K was really hot. I couldn't even touch it. And I have nothing to point with around here. I don't like lead pencils because it's carbon. So, okay, this one got really hot last night. I burned the crap out of this thing, working with this thing. So I gotta check that 1 meg. I heated that son of a gun up like crazy. This one here was hot last night. I don't remember that one. So here's the speech amplifier. They got 470 Ks on the plate to the B plus bypass capacitor there. 33K to the B plus runs into this stuff. This I put back. This is the volume control, I guess. What a nice place to stick that. So this one is the 6DE7, I think it's called. So I redid this stuff last night. I chose to put, going through my crap, I found 2 of these fireproofers. They're very short lead, so I had to put extensions on both sides. I put my highest voltage 47 on the B plus. This is actually the B plus takeoff that operates the plate to the 61, 62, and is that what it's called? And the so that is supplying that one, and it's also supplying something else, the plate to the modulator. That's where that 1 meg is that I heat the crap out of. I have to measure that. Lots of clean shots. You don't even have to remove the tube for that. But that's the pink path is that. So that's the only thing on the high the 750 volts. And the other ones are on this blue line, which is the BFO thing. It shows 300. I didn't measure that today. This is where it's fed from. It goes on to the other page. And this one here has to do with modulation for, okay, this is modulator tube. So this yellowy stuff is when it gets switched on for modulation, and it wiggles back to the grid number 2 when it runs at 65 volts, not milliamps. I see that AM, I think milliamps. 65 volts. I don't think it's right. 180 volts. I don't remember. None of that stuff. Last night I had such hot resistors, it was unbelievable. So I'll have to turn it back on and temperature test that. This one felt a little warm. This thing I felt was warm last night too. That's cold. So on the power supply, I just decided to get rid of this big green thing, because this thing was loading it down. This is 30,000 divided into 2, so it was 14,000 per side. And if the schematic shows, I gotta get some tape and tape those together. Shows 100K on each side. I know old Fender amps use the 100K for balancing the voltage across each capacitor. And then the newer amps have 220K, so that's how I chose that, because what Fender does. Red, red, yellow. 5%, I think. Fireproof. Silver. So, and this is the one with the question mark. Again, it ended up on the highest voltage. Stepped on from this thing, but it's still at my highest voltage. I don't know. I wanted to keep it high so I can get at it to pull it out. And I made a horrible mistake here. I had this soldered. This is the positive. I had this one soldered right in here to ground. I had that wire right there soldered into there, and I'm looking it over, and I thought, well, hell, that can't be there, because I'm getting 750 volts and my capacitor is only worth 450, so I'm glad I saw that, or I would have had a hell of a explosion. This SOB would have been that would have been bad. So I caught it, thank God, because I'd hate to have that blow up in my face. I usually don't work with this kind of voltage. 750, I don't usually do it. I wonder if I could put an 807 tube in here. I got some 807s. Oh, that takes that other kind of socket. So I put my finger on that RFC, that big RFC on the top side. I did this. I went back to this. I put two blue 1,600 picofarads, so that one goes wherever it is here to chassis, and one goes from here to chassis. I had a hell of a time working with this stuff. I should have just cut everything out of it and cleaned it, and it was a real pain in the assets. I had to replace this one, but this thing I could hardly solder to it. My solder joints still don't look good. There. That one's alright. This one here looks kind of. I'm still don't like it. I'd like to redo it. And this one here, I thought I had that point right here clean well, but it's soldered. But the first time I broke it out, so. But I thought I cleaned that really good, but it wouldn't solder. So I'm still would like to do this area of it, but I'm not going to go to that polarizing thing. I'm keeping this on. I like these things. Two fuses, hot and neutral, and what does it matter as long as the capacitors don't go bad? And it's not dangerous. People say it's dangerous. It ain't dangerous, or there'd be zillions of dead people out there with guitar amps. Guitar amps is where it's the most dangerous, because they put the switch on the neutral, so you shut it off, and then the hot swings around the filaments or the transformer windings, because you can always hear your guitar amps when they shut off. They go buzzy, a higher frequency buzz, and you know it's AC swinging around. You would think they would have figured that out, but they didn't. So this is it on this one, I guess. I'll see what happens with it. I have no crystals. I can't transmit it anyways. I'll just hook a light bulb up to it and see what happens with it. But I'm going to hook up the box, the antenna box, and do it right. But it's coming around, nothing, you know. So I touched this. This was cold. I watched the voltage come down to about 50, and then I touched it. That resistor's wiped out. I'm going to redo this so it's straight, the way it's supposed to be, without cutting a wire. I will hook this back into here and disconnect this one. Disconnect it here from there. Go back to original, and then well, I guess it must have been this solder connection or that solder connection, but I still didn't measure 447 ohms or whatever. I measured a half a ohm, which my meter always sets when I put the leads together, about 0.5 or 0.6 ohms. But I did take this apart and I put Vaseline in there and wiggle it around. So maybe that had something to do with it. I don't know. Nothing's oscillating, so I can't see that being a, whether that's there or not, it shouldn't matter. Just running the DC through it, it shouldn't matter. And it worked with these in there. So I don't know. Next step, I don't know what the next step will be. Well, I wanted to monitor this thing. I think I'll try it real quick. Back on here. So I have this on plates, so that's interrupting the cathode, I guess. Measuring that way. So as soon as this comes on, the standby thing is eliminated. So as soon as I come on, it'll be high voltage will be on in all spots. See, she's on. She's going. And this one's a negative control grid voltage. This is on the negative power supply. This one. Maybe nothing's working. It should show negative grid voltage. Come on, tune. Standby, AM. Tune. It's got 7 B plus. Negative power supply, so it's got to, I'll hook my meter up to it. Maybe it's got to oscillate for that to come up, but I thought that was negative control grid voltage. Where's the knobs here? That one doing nothing. I'll leave it at 12 o'clock. This one, it's not going to matter. I'll try this. Well, this one's on the, have this up. Oh, loading. That's the plate. So I'll put it plate. Oh, that's nothing. I don't know what that does. Well, I don't have fire. That's a good thing. I'll check that voltage again. Back on. We'll get the old voltage here. Right there. 740. I smell resistors getting hot. I'll call it 740. $43, $44. 45, 46, 45, 745 volts. The big green resistor's gone. Nothing here. That means the tube's not doing nothing. Should show something. Maybe this ain't working. It was working. I seen it go way up, and I had it on grid. When I was having my fire, it was going way up, but I still couldn't tell what was burning at the time. I'll shut it off. It takes a while. It's still glowing. See, with that big 30,000 across, it would go up quicker, obviously. This one goes out within reason. That's only 100 volts. So you'll use it like this. There's no standby. Whatever a standby is, it ain't a standby. I'm thinking about putting a toggle switch here, maybe. Or throw it in the garbage. And these here, oops, see, it's off now. Test these. That's cold, so that's not being abused. I'll unplug it here. This thing here should be cold. I don't have voltage in it, but it's not much. It's down by now. I don't know how hot that gets. It's not bad. It's not conducting like a power tube should. So I'll have to test that one. This one's probably hot. Yeah, it's still hot. This one here, not bad. That one gets hot. Wasn't there one up here? Not bad. This one K here gets hot, I think. This one here. I didn't test that domino capacitor. So there's really no capacitors. I want to take the one that hooks up to the control grid here, and wherever it comes from. It comes from that one, I think. So I don't know where it's at. This one. And also